section 2 of this, you're actually not going to be getting anything like new. We've already learned all the skills that we need, which is Pythagoras and trig. You're still using those exact same things we've been using throughout the week. The only difference now with this one is it's going to have at least 2 triangles in the questions now. And the general rule of thumb that's going to be happening here is we're going to have to break down the situation. Oh, come on. Highlighter. We're going to have to break down the situation and work in steps to solve this. And what we're usually going to have to do is we're going to have to figure out something from one triangle to get the value of like a side in another triangle. So for example here, maybe for this one, we would need to figure something out about this left triangle. We need to do something with that to figure out like the length of a side and then use that to solve this other triangle. So that's the general like thing that's going to be happening for this. So you're not actually getting taught anything new. It's slightly more complicated problems in that it's multiple steps now. Something else we're going to also need to know here is you're going to need to know about the angles. And something that's important to know about angles is that triangles and straight lines, that's what that is, are 180 degrees. So the angles in a triangle are 180 degrees. And for a straight line, the angles that go along that straight line are going to be 180 degrees. So angles equal out to 180 degrees is essentially the only other thing we're going to really need to know here. And that's only in a couple things. Sorry. So let's actually get started on this one here. So again, if I were to just give you, like, imagine this left triangle here didn't exist. This is something we've seen before. It's a triangle. We need to figure out what we need to do with it. In this case, though, what we're trying to do for this triangle is we're trying to figure out the length of X and the length of Y. We're trying to figure out the length of this side that I'm highlighted in red and the length of this side that I'm highlighted in red. So there's 2 separate things that need to happen there. So what I'm going to do is I'm going to look at, I need to be able to, which of these triangles can I solve? So between these 2 triangles, don't draw what I'm putting here. Don't draw what I'm putting here. I'm just drawing them out separately. This is not a bad idea to do your whiteboards for, is literally draw the triangle separately and see which ones are solvable. 66, this one's 40. You don't need to draw this in your book. You will not have space otherwise. X and X. So we always need 2 things to be able to solve a triangle, right? We either need 2 sides or we need an angle and a side. We need 2 things to find a third thing. That's what we've been doing all week. Which of these 2 triangles, triangle 1 or triangle 2, has 2 things we could use to find a third thing? It's triangle 2, you betcha. So we need to try and find X first then, right? So we need to find X first. That's our first goal. So I'm going to find X first. So I'm going to put a little X here, put a little underline. That's how I know that this stuff here is all about X. So this is triangle X here, right? This right triangle. So do you think I'm going to have to use Pythagoras or am I going to have to use trigonometry here? Is there an angle we have to use? We have to use trig, right? There's an angle we have to use. So I'm going to label my sides. This is my hypotenuse. This is my angle, which means this side over here, the blank one's opposite, and then this side over here is my adjacent. Which 2 sides have something we can work with? H and A, right? A because it's 6.4 and H because that's what we're trying to find. So if you're looking at SOHCAHTOA, which of those has A and H? Cosine, you betcha. So I put my formula in, right? So cosine, that's this thing right here. It has A and H. So I put cosine of the angle, so theta, is equal to, I'm just going to put A and H here because I'm lazy and all mathematicians are. I'm going to make that a little bit better though. So A and H. Cool. So next I'm going to do is I'm just going to substitute my stuff in, right? So what am I going to put here, Austin? So what am I going to put next now? I'm going to substitute my stuff in. Yeah, so what am I going to put? You betcha. equals 6.4 over h, you bet. You could put x here as well. In fact, I'm going to put x just because I labeled it up here, but you could use h, Austin. That's okay. That's fine. Doesn't change anything, just changes the what this is called. So what my next step is, I need to get x by itself, right? This is usually the hard part, is the algebra part of it. This is going to be a two-stepper, right? You betcha. Because I need to get x onto one of the tops of each side first. Need to get on top of one of the sides. So what I need to do is I need to get rid of this fraction with x on the bottom. So I'm going to do the opposite. So right now 6.4 is being divided by x. So now what I'm going to do is I'm going to times it by x instead. So I'm going to times that by x. And not just one side, I'm going to do both sides, right? And if I do that, I'm going to get cosine of 40. Is that big enough for everyone? Okay, times x is equal to, these cancel out, right? So all of a sudden, I'm just going to be left with 6.4. Little thing here. Oh, why is it times it by x? Because I need to get it on top of one of the sides. Right now, it's on the bottom of a fraction. So I need to get x by itself, right? So right now it's on the bottom of a fraction. It's being, so 6.4 is being divided by x. So I'm going to do the opposite of dividing by x. I'm going to times by x. So once I've done that, now all I need to do is now I need to get x by itself, right? And this cosine of 40 is in the way. So now I'm going to do is I'm going to get rid of that. So instead of cosine of 40 being times into x, I'm going to divide it by cosine of 40. I don't have space, so I'm just going to put divide. I'm not going to put that cos 40 there. But if I do that, I should end up, this is going to get canceled out. And I'm just going to be left with x is equal to 6.4 divided by cosine of 40. And if you end up punching that into your calculator, you're going to end up getting x is equal to 8.36 meters. I'm just going to like box that because that's pretty important. Cool. So remember, the goal of this was to find x and y. We found x first because we needed to figure out what this side is, right? It's the only one we could start first. Now, all of a sudden, I know that this x right here has a value. So now this triangle on the left has two things. It has two things that I can use to find a third. It has an angle, and now I know that one of the sides is 8.36 meters.
That's not 8.35.
Did I mess up there? 6.5. Let me load my calculator here because I just loaded up there. Come on. So 6.4 divided by cosine of 40. Oh, so this 6 rounds up this to a 5, which rounds up this to a 6. Sorry? You go as far right as you can, like as long as stuff keeps changing. So normally we just do 2 decimal places, but when we look at this one, but this one, if we're rounding it, this is still going to get bigger. You know, if you put 8.35 there or 8.36, you get full marks. Okay, so I had to figure out what x is because now I have 2 sides on my left triangle, right? So now I can figure out what my y is because now my left triangle has 2 things. So if I'm looking at this, I'm going to label my sides. This is my hypotenuse. This over here is my opposite side, which means this is my adjacent. Stephen, which 2 sides have something I can use? The adjacent, yeah, because it has the y, that's what we're trying to find. And the O, you betcha, because the opposite, we know what that is now, you bet. So which ones use O and A in SOHCAHTOA? Tangent, you betcha. So tangent is equal to tangent of the angle is equal to opposite over adjacent.
So this x hypotenuse.
Mhm. X in this case is the
The
hypotenuse.
other one, I meant,
Oh, no, the hypotenuse is gonna be opposite of the right angle.
so. What's 8.35?
8.3. Oh, that's this line right here in red.
That's what.
Yeah, oh, that's the opposite side.
Oh, what? I was
Um,
talking about the other triangle.
it is the hypotenuse of this right triangle.
Yeah.
Yes. Yeah, but on the left triangle, it's no longer the hypotenuse. Yeah, good question. So I have my formula now. All I do is I fill it in, right? So now tangent, my angle is 68. I'll make that a little bit bigger here. So it's tangent of 68 is equal to my opposite. I know what that is. That is 8.36 divided by, I'm just going to put y in this case, but it's adjacent. 8.36. Yeah. Sorry. You're right. So I was actually about to ask you what the next step is. So we're going to times both sides by y. I'm not going to put the arrows this time just because I don't have a lot of space. You can do the arrows if you want. So I'm going to do, so I'm timesing both sides by y. So now I'm going to get, I'm putting a little circle here in this case. You don't have to, but this is the same thing as that little x. It's the multiplier, right? I'm just going to put that just because it's a little bit easier for me to do. But that means that times symbol. So y times tangent of 68. And what's on the right side here, Kim? After I've times both sides by y, what do I have on this right side?
Or 8.36?
Yeah, just 8.36, you bet, because those two y's cancel each other out.
Oh, shit.
Okay, and now I have one more step. I need to get y by itself. I need to get rid of this tangent, right? So y is going to be equal to, divide both sides by tangent. That cancels this thing out. It's going to be equal to 8.36
What the?
over
You punch things to the-
tangent of 68. You could use the opposite if you want, Kim.
8.6.
Isn't it equal to the possibility that these things are just as we are?
Divided by tangent. Yeah, yeah. 8.36 divided by tangent of 68. And that's going to give me my answer here, which is 3.38. 3.38 meters squared. Not squared, not squared. And that's my y, right? This is technically what my y is. I'm going to box that. I've solved my question. I have my two answers. I'm done. Now, question I have for you. How come I'm dividing by tangent? How come I don't use this second function tan thing there? How come I don't use that? This is usually the hardest part about trig, which is why I really want to make sure we understand it. So how come I do not use, I'm dividing by tangent here, right? How come I'm not using that inverse little thing, that second function?
Because it's not squared.
Good guess, not quite. So the reason we do that, we only use the inverse function if I'm trying to separate the tangent or the cosine or the sine from the angle. So that's only if I want to get the angle only. I brought the angle over as well in this case, which is why I got rid of it entirely. Which is why I didn't use that inverse. You only use that inverse if you're trying to find the angle itself. So I hope that makes sense there. It's still the same stuff. You're still doing one triangle at a time. The difference now though is we need to change our approach in how we do it. We have to look at a triangle and we have to look for the one that has how many parts? 2 parts, you betcha. Yeah. So we're only going to do one more example, actually. You're going to start seeing some more of these as well, word problems. And whenever you see a word problem, the best thing you can ever do for yourself is draw a diagram. I can get a, I do have a couple more things. Yeah, they kind of run out after a while. Who is calling me? Okay. So, question 2, best thing we can ever do for ourselves when we see a word problem is draw a diagram of the problem. It will save us a heck of a lot of time. So what I'm going to do is I'm going to draw a diagram. So I have a flagpole that's supported by it's called 2 guy wires. They're support wires. Each is attached to a peg in the ground 4 meters from the base of the pole. And the wires have angles of elevation of 35 degrees and 45 degrees. Okay, so I have a flagpole. So I'm going to draw that. There, it's a nice flag up there. Put a little M for Mario. Whenever I think of flagpoles, that's what I think of. So it's supported by 2 guy wires. Each are from the ground 4 meters from the base of the pole. So those are the support wires you see sometimes, like this. So those are these things here. Now, one of them has an angle of 35 degrees down here. I'm going to put 35. The other has an angle of 45. And these are both 4 meters from the flagpole. So cool, I now have a diagram. I apologize, it's not that big there, but the angles are 35 and then 45.
So the angle of 35 is bigger?
Oh, so yeah, angle of 35, it would end up going a little bit taller in this case, right? Because you're really all you're doing is you're changing the. No, I have that the other way. That's okay. I should have had 45 over here and 35 over here. Yeah. But your diagram doesn't need to be perfect. Okay, so next step we need to figure out what the heck we're doing. So what the question's asking me is, I want to know how much higher up the flagpole is my top wire attached. So what it's asking me to figure out is the distance of, I'm going to zoom in a little bit here. It wants me to find the distance of this little blue part here, right? How much higher is the one wire from the other wire? That's what it's asking me. So what I'm going to do is, so first off, how can we figure this out? Don't use like complicated math stuff. Tell me in plain English. Sorry?
10.
Nice guess. Not quite. Oh, so you're talking to me in math. Tell me in English. How can I figure out the length of this blue thing based off what I know here?
So let's see. We don't know.
There's a way we can know. So can't I just take?
What is that, 4 meters from the base?
They're both 4 feet from the base. Yeah. So how I can figure out the length of this blue thing here? I'm going to use green for this.
Say like an inch.
So how I can figure this out? I can just figure out the length of the tallest one and take away the length of the shorter one, right? So can't I just figure out the length of this, the taller one, take away the length of the shorter one? That gives me what I have, right?
Then how are you gonna know? Like, don't figure that out.
Oh, so you're right. I need to figure out those heights, but that's how I'm going to find the ultimate answer. Is I'm going to take the height of the big one, take away the height of the smaller one, and that's going to give me the leftover height, right? So that's it in English. Now, how am I going to do that? Well, I need to now look at my triangle.
You have the answer key?
I do.
Did you give it to us?
I actually have a better answer key for this. I'll show you after this question. So what I'm gonna need to do here. So first off, if I look at these triangles, which one has two things? Both of them do, right? So it doesn't matter which one I start with then. They both have two things. They have two things, and I'm trying to find. So I'm going to call this little thing here Z. That's the one I'm trying to find. I'm trying to find the height of the one side with the taller wire, and then the height of the other side with a smaller wire. So I have an X, a Z, and a Y. Does it make sense where I got those numbers from?
What does that look like?
Mario.
Oh,
I listened to a podcast on Mario this morning, so that's why that was in my head.
isn't there a circle around it? No?
I think there normally is, yeah. I haven't played this like Super Nintendo in years. Okay, so cool. I figured out what I need to do. And I can start with either side. So what I'm going to do is I'm just going to say, why don't I start with the left part of it? I'm just going to start with the left wire. So left.
So you can just design it like,
Sorry?
as you can just make a draw.
Yeah, if you want. I just wanted to make sure like that this is the flagpole. You could just do a straight line if you wanted to. So I'm going to start with this left one here. My angle here is 35. Which two sides, hypotenuse, adjacent, opposite, which two sides have something there? Adjacent does, yeah, that's this one. And well, the hypotenuse is this blank thing, right?
So, the adjacent, the,
Yeah, the adjacent and the opposite one here, right? Yeah. How do I know? Well, this is my hypotenuse up here, right? And there's nothing there.
yeah,
So I'm trying, what I know that this thing's for, and this is what I'm trying to find. So those are the two sides I'm going to use. Yeah.
so,
So I'm using opposite and adjacent. That is going to be TOA. So that's going to be tangent of the angle is equal to opposite over adjacent.
I'll call this one.
So tangent of 35 degrees is equal to the opposite. In this case is going to be my X, right? So I'm just going to put that X. That's what I'm trying to find. And my adjacent is 4 feet. Sorry? We're going to, you betcha. Yeah, that's exactly what we're going to do. We're going to times both sides by 4. Times both sides by 4. And I'm going to be left with, so tangent of 35. I know that's a little messy. I do apologize. Times 4 is equal to just X, because these two things cancel each other out. I'm going to erase that, make that a little neater. Tangent of 35 is times 4 is equal to X. And then I can just plug that into my calculator, can't I? Where's my calculator? I trust you there. I just realized I did my answer key wrong for that one. Times 4. Yeah, 2.8. So in this case, 2.8 is equal to X. And X is the length of one of the wires. It's the length of that left wire. So now I'm going to do, I've done the left one. Let's do the right one. So yeah, yeah, because I want to get rid of that fraction there. Okay. So for this right side here, I'm just going to draw this triangle. Don't draw this. I just want to make it a little bit easier to see. So do not draw this triangle. I'm just putting it over here so it's a little bit easier to see. Okay, so What I need to do is I need to, I need to label my triangle, right? So what, Austin, what side is this one gonna be? You betcha. Which means this one's gonna be our opposite, because it's opposite the angle, and this one's gonna be our adjacent. So which two sides am I gonna be using here? Well, which two sides here? It has to be adjacent because there's a 4, and then which one of the other ones has something? O does. So I'm going to use O and A, which means I'm going to use tangent. Okay, so I'm using that same ratio. So tangent tangent of theta is equal to opposite was y, adjacent was 4. So just like last one. So what I need to do now, sorry, I kind of skipped a step here. Sorry, this is supposed to be 45 degrees. I didn't put my blank formula in. I just immediately substituted it in. So we're just going to write it. So tangent of 45 is equal to y over 4. You betcha. I multiply by 4 in this case. So times both sides by 4. And I'm going to get tangent of 45 times 4 is equal to y. So y equals 4 times tangent of 45. So now we just got to plug that into our calculator there. Oh, is that the answer? Oh, okay. Oh, yeah, that is too. Okay. So it's just going to actually end up being 4 because tangent of 45 is 1. Y equals 4. Yeah. So I know our diagram's a little bit off because I made a mistake. Technically, the right side's the taller one.
Oh, I did the same thing.
I made a mistake there, but that's okay. Like we just need to kind of look at what we're doing here. So remember, to find this little thing here, I needed to take the taller one, subtract the smaller one, right? So I need to take the taller one, y, subtract the smaller one, x, and then that's going to give me my answer, which I said at the very, very start was z. That equals to 1.2. Yeah, 4 minus 2.8 is equal to what?
Okay, now I understand.
Yeah.
I still
I
don't
didn't
understand,
even
like, how
understand
the
that.
functions and shit works. Like, I know the math, but like, how to like the formulas that's used.
Okay, I can help out with that today then. Yeah, I can help out with that today. It really comes down to it, like with this one, this is the first time we really have to memorize something, which is that SOHCAHTOA. So we had to figure out how much higher up the flagpole is the top wire attached to it. So Z in this case was 1.2 meters. Now you're probably thinking of, everyone have that before I zoom down? Okay, I'll just do that. So the next question I have here is how long is each guy wire? That's the length that it runs up, right? That's what that is. Now, in this case, I'm going to redraw those two triangles here. Just filling in what we know now. Actually, let me just erase that really quickly. So I have my pole, I have my one wire, and I have my other wire. I know that's 4 and 4. This is 35. This is 45. And now I also know the length of it runs up the flagpole, right? The height. So I know this one over here is going to be 2.8. This one over here is going to be 4. So this question is asking me to figure out how long each one of these wires is. I'm just going to label them X and Y. You could do 1 and 2. You could do A and B, wire 1, wire 2, left wire, right wire. It doesn't matter. Label it whatever the heck you want. But I've just labeled them. So I need to try and find, in this case, I used X and Y again, because those are the two most common things you're ever going to see. how am I gonna figure out the length of that? Do I use Pythagoras or do I use trigonometry?
Can't you use? Oh,
Finish that thought, finish that thought. You're on the right track.
so what is 2.5? Can you use a square plus b square?
I can use trigonometry. I have two sides of a triangle and I'm trying to find a third one. I can use Pythagoras. I have two sides. I'm trying to find a third one. I can use Pythagoras. You can also use trigonometry here though, because you do have an angle to work with. So you can use either one you want. Either one works. Either way, you're going to end up with the length of that side if you set it up right. I'm going to use Pythagoras just as a refresher here, because that's where everyone's heads seem to go first. So I have two sides. I'm trying to find the length of a third side. Let's figure out x first. That's the left one, right? So a squared plus b squared plus c squared. On this left triangle, which one of these three is my hypotenuse? 2.9 is the length of this height, right? Oh, it's 2.8, sorry. Yeah, it's kind of messy there. It's 2.8. So-
I think
Hypotenuse is always opposite of our right angle. So the right angle is that little square. So in this case, yeah, so C is going to be X. Which means the other two are just A and B. Well, not quite divide. Oh, this line? Oh, I was just showing. Oh, this thing here, because that was a mistake. Oh, no worries. Yeah. So all I need to do now is substitute my values, right? So 2.8 squared plus 4 squared. So if I'm just going to do this all in one motion now. So I'm just going to go 2.8 squared plus 4 squared is going to end up giving me 23.84. So when you square these and add them together, you get 23.84. So I just combined two steps in one. You can do that. That's fine. So that's the next step. You're right. And how come I'm taking the square root there, Jasmine? You're correct. Well, yeah, I need to get rid of this squared thing, right? There's a little 2 attached to this x. The way to get rid of that squared is to take the square root. And because I'm doing it to one side, I got to do it to the other side. You betcha. 4.88 is the length of my left wire, or of x. 4.88 meters. That's the final answer. I'm going to circle that. So next thing I need to solve is I need to figure out what my y is, right? I need to use my other side. So I'm going to do the y side now. So I'm going to use Pythagoras here as well. So a squared plus b squared equals c squared. What is my hypotenuse? Do I know it? So if it's of the right triangle there, what's the hypotenuse? It's the y, right? Because it's opposite that right angle. So I'm going to put that in for C. And I'm just going to put the other stuff here. So 4 squared plus 4 squared. If you plug that into a calculator, that's going to end up giving you 32. Exactly, just 32. Equals y squared. And my next step, Austin? What's my next step here? I need to get rid of this little 2 here, right? I need to get rid of the squared. What's square root? That's the opposite, you bet. So take the square root of both sides. So square root of 32. Yeah, 5.66. 5.66 meters. Oh my gosh, that's really poorly written. There we go. So 5.66 meters is equal to Y. That's the final answer. I'm going to circle it. Okay. So, in answer to your question earlier, Kim, is there an answer key? Well, one, you guys do have your blue answer. You do have your green answer key. We're going to skip question 3, by the way. Oh,
I just want to.
okay. So we're going to skip question 3. Don't worry about it. We're not going to do it because it's kind of a weird question. Instead, what we're going to do is we're just going to go straight to these practice questions. Now, these are not easy questions, right? These are multiple step questions that involves complicated processes, involves trigonometry and Pythagoras. So what I've done, you have your answer key. You have your green sheet answer key. Cool. That tells you if you got it right or wrong, but it might not help you lead you to the answer. So what I've actually done now is I have taken all of that and I've actually uploaded a key. So you can find that on the LMS. If you click on that and download it, wait for my slow computer to do it. Wait for my slow computer. 4.2 answer key. And I open that up. You're going to end up getting something that looks like this. And so this is actually the steps to solve every single one of these questions now. Now, for most of them on the left side, what you can find is you can find in very scribbly writing, because I'm going to tell you right now, you don't have a lot of space. You might want to use the whiteboard for this. Some of the steps to do it. Eventually, once I got into like the last questions, I got a little lazy, stopped doing the steps. But there's some steps on how to solve it as well. So you can use that as a reference point. Don't just like look at it and go, I have all the answers now. That doesn't help you learn it, right? But I know these are difficult questions, so I uploaded a guide to help you figure out at least how to start solving them. But as you can see, and I wrote small, it is a little cramped. So don't be afraid about using loose leaf or using your whiteboard or something, or shortening a step. So instead of putting, the blank formula, maybe just go straight to filling it in. Instead of sine of theta is equal to opposite over h, sine of 53 is O to 4.9, and then do it, right? Save some lines, that's okay. But I just wanted to point that out. You don't have a lot of space to work with sometimes. Okay. So you have that up there. So we're probably moving on tomorrow. I'll see. But yeah, so this is some time to keep working on with some practice questions here. And once you get to these last few, draw yourself a diagram, make it a heck of a lot easier for yourself.